Hi there, Grade 12s. Let's get into the 2022 November Paper 1, Question 1, Algebra and Inequalities. Question 1 asks you to solve for x in various situations. 1.1.1 has a quadratic equation that's already been factorized. We can start straight away by just setting each of these factors equal to 0. We solve each of these equations in turn, and we'll find that our first solution is x equals 2, and our second solution is x equals negative 2. You can see it's a simple 2-mark question. So in this question, you would have got a mark, 1 mark for each answer. Having a look at question 1.1.2, we are required to solve another quadratic equation, but this time we're told to solve it correct to 2 decimal places. This means that we will be using the quadratic formula. When you're given a quadratic equation in the form of ax squared plus bx plus c, can be rearranged to have x on the left equaling negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. Using that formula, we can substitute the 2 instead of the a, the negative 6 instead of the b, and the 1 instead of the c into our quadratic formula. That will produce x is equal to a negative 6 plus or minus the square root of negative 6 squared minus 4 multiplied by 2 multiplied by 1. And that will all be divided by 2 multiplied by 2. Now all that remains is to put all of these figures into our calculator and get our answer. So here I have already entered the data in the calculator. Keep in mind that you have to have a negative b in your formula, and in this case that would make it a negative 6. Remember to either put in your calculator negative open bracket negative 6 or write this in your calculator as a positive 6. Subtracting the negative would cause that 6 to be a positive number. Right, once all those numbers are entered in correctly, then all we have to do is press the equal sign for the first of our 2 answers, change it from standard to decimal form, and write our answer down correct to 2 decimal places. So that would be 3,16. Now for our second answer, instead of using the plus sign in this position, we've got to change it to a minus. Instead of re-putting all of this into your calculator again, just use the calculator back button until you get to the position of that positive sign, delete it and replace it with your negative sign and press equals. Change it from standard form to decimal form, and we'll get our answer correct to 2 decimal places would be negative 0,16. Okay, and here we have finished question 1.1.2. Let's have a look at where the marks come from. For showing that you understand the quadratic formula and have substituted into it correctly, you would receive a mark. And then you would get a mark for each of your answers, totaling your 3 marks for question 1.1.2. Question 1.1.3 asks us to solve an inequality where x squared minus 90 is greater than x. Our first step is to arrange this inequality into standard form. That means where all terms are on one side of the inequality sign and 0 is left on the other. Terms arranged in descending powers of x. Factorizing this expression will convert it to x minus 10 multiplied by x plus 9 is greater than or equal to 0. Our next step is to extract our critical values. We obtain our critical values by setting each of these factors equal to 0. So we would say x minus 10 is equal to 0, and also x plus 9 is equal to 0. This gives us one critical value of a positive 10 and another critical value of negative 9. Now, to communicate our final answer to this question, it will help for us to be able to visualize this question as a function. If this expression, x squared minus x minus 90, were drawn as a function of x, it would make a parabolic shape, and the two intercepts on the x-axis would come from our two critical values. The first intercept would be negative 9, and the second would be a positive 10. Now, if we look back at our expression, we are interested in all of the x values which produce output values greater than 0. So all of our input values of x that map onto positive output values, where are they? Well, we see that input values that are less than negative 9 map onto positive output values. Soon as x is equal to negative 9, our output value is 0. Now, anything bigger than negative 9 and remaining less than negative 10, that would give us negative output values. We're not interested in the negative output values. We are interested in the output values greater than 0. And then we see that any x value that is greater than negative 10 maps onto an output value that is greater than 0. So we see that, right, when x is less than negative 9, we get positive output values. When x is greater than 10, we also get positive output values. So this means that x must be less than negative 9, or x would need to be greater than 10. Where would our marks come from this question? In solving this question, rearranging your inequality into standard form would earn you 1 of your 4 marks. Factorizing it would earn another mark. Then, having your correct inequality sign would get you your next 2 marks for this question. Question 1.1.4 asks us to solve an equation that has our variable as a surd. Our first step in these equations is to always isolate the term that has the surd in it. So this would mean removing the positive x, subtracting it from both sides. We would get negative 7 multiplied by the root of x equals 12, negative 12, subtract x. Now what might help here is to multiply every single term by negative 1, so that we have 7 root x equals 12 plus x. And instead of 12 plus x, it might be easier just to think of that as x plus 12. So in our next line of working, where we have to square both sides, where we've got to square the 7 root x, and we need to square the 12 plus x, it might be easier to think of that as x plus 12. And we will square both sides. On the left-hand side, we'd end up with 49x, and on the right, we would end up with x squared plus 24x plus 144. So if we rearrange this equation, we'll be left with 0 on the left by subtracting 49x from both sides, giving us on the right x squared subtract 25x plus 144. Now this equation can be solved by factorizing. And the factors that would multiply together to make 144 and would add together to make a negative 25 would be 16 and 9. So we would have x minus 9 in one bracket, x minus 16 in another. Now you might think, we might not find it so easy to know what we multiply to make 144, and the same numbers must add together to make 25. If that is the case for you, then you could actually use the quadratic formula. But having used factorizing, we'd set each of these factors equal to 0, and then we'd get the final two answers for our question. Now, an equation that has surds. Now, when it comes to verifying each of these answers to check if they are acceptable answers to this equation, we see that both of our solutions are positive numbers, and they're both square numbers. So if we were to substitute 9 in for x, we would see that finding 7 multiplied by the root of 9 would give us 21, and 12 plus 9 is 21. So this answer checks out. We know that we can accept that answer. X equals 16, substituting it in for x, we would find that 7 times root 16 is the same as 7 times 4, which is 28. 12 plus 16 is 28. So both of these answers check out. Usually when you have an equation with surds, you're going to have to verify each answer, and one of them you may have to reject. Okay, where do our marks come from in this question? Number one, you got 4 marks here. For isolating the surd, you would get a mark. For correctly squaring both sides, you would get a mark. And then completing all the algebra down to get each of your answers, you'll get a mark for each answer. And that's where you would pick up your 4 marks for this question. Question 1.3 asks us to solve simultaneously for x and y, where 2x minus y equals 2 forms your first equation, and xy equals 4 forms your second equation. It's usually best to start with the linear equation and isolate a variable. The easiest variable to isolate will be the variable that has a coefficient of 1 or maybe negative 1. In this case, it's the y. So we can isolate this y on the left-hand side, and we do that by subtracting 2x from both sides as our first step. So that'll be 2 minus 2x. Then multiplying through by negative 1 would give us a positive y, which will be easier to work with. And that would yield y equals a negative 2 plus a 2x. But again, much better and easier to work with if we wrote it as 2x subtract 2. All right, we have isolated a variable in our linear equation. Now what we need to do is we need to substitute that variable into the second equation. Wherever we see the letter y in the second equation, we will now replace it with the expression 2x minus 2. So here we go. In our second equation, we would have x, and then in place of the y, 2x minus 2, and that would be equal to 4. Expanding out the brackets would produce 2x squared minus 2x is equal to 4. Putting it in standard form would be 2x squared minus 2x minus 4 is equal to 0. Dividing through by 2, by the common factor of 2, would leave us with x squared minus x minus 2 is equal to 0. Now this quadratic equation, we see we have a single variable x, and the expression can be factorized into 2 factors, those factors being x subtract 2 and x add 1. This would mean that x minus 2 is equal to 0, or x plus 1 is equal to 0, giving our 2 x values as x equals 2 or x equals negative 1. Now we've solved our x values, but we need to find the corresponding set of y values based on these 2 x values. So we've reached the stage where we have solved the equation. We've found the x values that satisfy the set of equations. But now we need to find each of these x values corresponding y value. And we can do that by substituting each x value in turn into our linear equation. And it will be easiest to use the linear equation that's in the form y equals 2x minus 2. Let's make a start with x equals 2. So when x equals 2 and y equals 2x minus 2, that would mean that y is equal to 2 multiplied by 2 minus 2, which is just 2. 2 times 2 is 4. Subtract 2 brings us back down to 2. And when x is equal to negative 1, and y is equal to 2x minus 2. That would mean y equals 2 multiplied by negative 2, subtract 2, and I've just written a 2 in the wrong place there. Let me correct myself before we continue. Negative 1 gets substituted in for the x. Now 2 multiplied by negative 1 makes negative 2 minus another 2. Y would be equal to negative 4. Okay, so let's have a look where we would get our marks in this question. First of all, for isolating the y variable, for isolating y in the linear equation, you would get 1 mark. For substituting this into your second equation, you'll get another mark. Getting the equation into standard form and factorizing, that would be another mark. And then we get a mark for our x values. Using your x values correctly to find the correct y values, then you would get the last of your 5 marks. Okay, question 1.3 asks us to show that 2 multiplied by 5 to the n minus 5, 2 multiplied by 5 to the n minus 5 to the n plus 1 plus 5 to the n plus 2 is even for all positive integer values of n. When you ask to show that something is even, that basically can just mean a multiple of 2. So we need to show that this expression here is a multiple of 2. And to show that something is a multiple of 2, you can show that 2 is a common factor, that 2 is a factor of this whole expression. So let's manipulate this expression until we can see that we can take out 2 as a common factor. Okay, now 5 to the n plus 1 can be rewritten as 5 to the n multiplied by 5. 5 to the n plus 2 can be rewritten as 5 to the n multiplied by 5 to the 2. Now we see we have 3 terms in this expression, each with 5 to the n. So we've got 2 multiplied by 5 to the n, subtract 5, well, what kind of 5 is that? Subtract 5 times 5 to the n plus 5 squared times 5 to the n. Now, if we just imagined if we could do this, this step may not be necessary, but it may be easier for some, may make it easier for some to see it this way. Let's say let 5 to the n equal k. Again, this may not be necessary, but it could help. So if we said let 5 to the n equal k, that means we could substitute k in for every time that we see 5 to the n. So that would be 2k minus 5k. And let's just square this. See what I've written there. I have mistakenly written a 2 instead of an n. And let's square that 5, and that would be 25k. Now we can see we have like terms that we can combine. 2 subtract 5 is negative 3. Then the negative 3 added to the 25, that would make 22k. And what is 22k? Well, it's 22 multiplied by 5 to the n, because k, 5 to the n is equal to k, which can be rewritten as 2 multiplied by 11 times 5 to the n. Just taking out a common factor of 2, rewriting that 22 rather as 2 times 11. And there you have it. You've done it. You have shown that 2 to the 5n minus 5 to the n plus 1 plus 5 to the n plus 2 is even. You have shown that by showing that the whole expression has 2 as a factor. And we could finish off by saying, therefore, 2 multiplied by 5 to the n minus 5 to the n plus 1 plus 5 to the n plus 2 is even for all positive integer values of n. Now what I've done there is I've just rewritten the statement that we are required to prove. Now, if you don't write that in, you might not lose marks, but it is a good idea to write it in. Now, having a look at where your 3 marks could come from, I would say that the first of your 3 marks would come by rearranging this to split the powers with the compound exponents. That is possibly where you would get 1 mark. Then your next mark would be to combine them all together to 22k. And I'd imagine taking out your common factor of 2 would get you your 3rd mark. And there you have it. That's where our 3 marks would come for this question.